Hello everyone, this is day 6 of our statistics for data science playlist. So today in day 6 our topic is median, and in the previous video we already have completed up to mean, and if you have not seen that video please do complete that and then you can continue from this part. So let's start. So first of all we need to know about what is median, because we already have mean, we already have seen mean, but today we are going to learn median. Now why median, why not mean? Because median is also a measurements of, this is also measurements of central tendency, measurement of central tendency. But there is a huge problem with mean, that is the outliers, the presence of outliers or the effects of outliers, which is actually or quite disturbing for mean. Okay, so if you want to know the exact central tendency measurement for a data which consists of huge outliers, for that case you can go for median. Now, how it is possible? So, first of all, we need to know what. So, we have to start from what. What is median? What is median? Now, median is something, it's actually the middle value. So, median is what? Median is the middle value. Median is the middle value of some data points. Now you have some data points and you are going to find the data points. But point to be noted that those points has to be arranged in order. So this data point should be arranged in order. Otherwise, you can't get the median. So always in the ordered data points, you can get the middle value. Okay, that means that median is that value which is actually splitting the entire data set into 50-50. Like let's suppose I have a data which is in bell shaped, which is in properly bell shaped. Okay, so if I have this type of data which is properly in bell shaped, so there will be only one point which will be cutting the entire data set into 50-50. Now this will be this value which will be cutting entire data points into 50-50, and this will be the central tendency. So this central tendency you can have as median. Okay, so for symmetric data, as you can say, 50% of data lies below x and 50% of data lies above x. So that is what actually called median. Okay, so what are the steps to find out median? So let's find out median. So I'm just telling step 1. Step 1, here you have to arrange all the data points, all data point or the data into order. You need to make it in order. After then step 2, then only you can use the formula of median. So after that you can find the middle value. Now how to find the middle value? So let's understand this with an example. So I'm just taking a simple example with some value. Let's suppose I'm just mentioning some data 10, 30, 20, 50, 40 like this. Now here if I want to calculate the median from it, what should I do? So as a first step, so let's write the first step. So the first step will be to make it in order. So I'm just making it in order. So 10, 20, 30, 40 and 50. Now, which is the middle value? Now, by observing, this is very clear that this one is the middle value, because 30 is the value which is actually two values are in the left side and two values are in the right side. So, 30 is actually situated in the middle. So, simply you can say this is your median. This is your median. But by observation, it is possible. Let's suppose we have a very huge amount of data. That time what you can do? So for that case, let's suppose I have a very huge amount of data, like 10, 32. I'm just writing it in order: 42, 43, 77, 84, 99, then 101, 132, 156, sorry, 157, like this. Now for this case, are you going to calculate each and every middle point by observing? No. First thing, you need to see how much value it is there, how many points actually present here. So let's calculate the point: 1 2 3 4 5 6 7 8 9 10. Okay, let's add one more: 166. Okay, so now it is 11. Okay, so for this case, what will be the value then? What will be the median? So already I have written this in order. So step 1 completed. Now we are going for step 2. Now, as because here n is what? 11. So n is what? Odd. Now for odd, what you can do? Simply the median will be that value. It is basically what you will be doing: n plus 1 divided by 2 with value will be your answer. This formula will work. Means if n is 11 here, so 11 plus 1 by 2, what will be the value? 11 plus 1 is 2, 12 divided by 2, that means the sixth value. Now count the sixth value. Which one is the sixth value? So this is starting from 1 2 3 4 5 6. So this one will be your median. That's how you can calculate. Now the basic problem you will be facing with 10, instead of, like, I actually changed the value from 10 observation to 11 observation. Let's suppose you have 10 observation, then what you can do? Let's suppose you have 11, 32, 56 and 77. This four value you have, and let's suppose I want now to calculate the median for this value. Now, if you go for the median, there is no such value which is actually separating the rest of the values. Like there is no value which is actually splitting the entire data points into 50-50, or there is no middle value. Okay, so for this case, what will be your case? Let's suppose this is like here n is 4. Let's go with this example. So how to find the median? Already our step 1 already passed. It is in order only. So order checked. Now after that, what we can do? L- Here n by 12th value, just use n by 12th value plus n by 2 plus 1th value. Just write this 2 and divide this by 2. So basically you will be putting the average of this two value. Okay, so n by 12, so here it is 4 by 2, means the second value, plus this is the third value divided by 2. So, and by observation also, it is quite easy to guess that your median will fall almost here in between your 32 and 56. So we are just making a average of these two value, means 32 plus 56 divided by 2. If you do this, means your 88 divided by 2, 44. So 44 will be your median. So if you have odd number of observations or even number of observations, always your median will be like following these two formula. I'm just writing the two formula to find the median. So we have gone through two cases. Case 1, when your observation when your observation is odd. Now for observation, if it is odd, observation means all the values, all the data points, like number of observation. If it is odd, means n is odd, then the formula you will be following, that is median, and that median will be like n plus 1 by 2th. value, and make sure all the values should arranged in proper order. Now case 2. Now for case 2 means number of observations is even. If it is even means your n is even. Now if it is even, then what will be the formula for this? So for this case, n by 2th value plus you will be doing n by 2 plus 1th value. Now you have this 2 value. Now let's divide this by 2. So this will be your median. Okay, and you will be asking one question, like you may have the doubt that this arrangement should be in always ascending order. No, you can write in ascending or descending, but it should be in a proper order. It doesn't matter either it is ascending or descending, but it should follow the proper order. If you are not writing it in order, then this formula will not work. This formula only work for ordered data points. For ordered data points or data values. Okay, so this is what our median is. Now coming to the main thing, that is the outliers. Already I have told you the effect of outliers is very much disturbing for mean, so that's why we can't go with mean as a central tendency measurement for the data which is having some outliers. For that we will be seeing the effect, the effect of the effect of outliers, the effect of outliers for median. So what will be the effect? Now let's write some value which is having some outlier. Let's put one outlier here. So 10, 30, 20, 40, and I am just mentioning 10,000. Okay, 10,000 I am mentioning. So this 10,000 is properly one outlier here, because as you can see, these are all the values are ranging from 10 to 40. So this is the range of value. Here the range is what? Here the range is between 10 to 40, all the values lies. Now this is the value which is in odd and out, and this one will be called the outlier as per the definition of outliers we already have discussed. Now the thing is, if your situation is like this, your mean will be definitely affected by this presence of outliers, because whenever you are going to add this and divide this, the value will be very huge. Whereas when we do median, what is our first step to calculate median? First thing what we have to do, we have to make it in order. So we are just making in order 10, 20, and after that 30, after then 40, after then your 10,000 will be coming here. Now as because we are making it in order, so that's why whatever the value present in the edge, it doesn't matter, it only concerned about the middle value. Now for this the middle value is 30, so 30 will be the median. So there is no such contribution of this outliers, this is just a point in the edge. Okay, so no effect for outliers, and this is the huge benefit you can say for the median. Like if your data point contains a lot of outliers, then median will be the best solution as a central tendency measurement. So there will be no effect on median of outliers. Okay, now coming to another case which is skewed data set. Like one more thing I would like to mention, that is median. Median is better for skewed data. Like if your data points is properly skewed data, okay, so median is the better option for skewed data as a central tendency measurement. Okay, now what is a skewed data? If I go for skewed data, so it will be like this, like it can be positively skewed or it can be negatively skewed. If it is positively skewed, it will be like this. Okay, so as you can see here, all the values are very much positive, like outliers also present. Okay, presence of outliers it is there, but in one tell it is there. So this is what, like, high outlier present in the tell. Okay, so here the tell is on the right side. Okay, so presence of, this is also presence of high outliers, or better, um this is not a high outlier, it's better to say like skewed. Like the skewness, better to say this is right tailed. This is not like outliers, it's like right tail, an outlier present in tail only. Okay, so this is the right tail. Or let's suppose you have left tail also, left tailed skewed data set, like it is looking like this. Okay, so this is what. Now for both cases, if you see, for mean, so mean is actually for the skewed data, mean will be coming in this point, but this is not a central point, and on the same way, mean is also coming in this point. Okay, this is what your mean is, your mean will be coming in this point. So as you can see, like here the frequency, like all the values, mostly the values are in this hump, right? So the frequency is actually influencing your mean or affecting your mean. That's why mean is not coming in the central part. Now to get the idea as a measurement of the central tendency, here for these two cases of skewed data set, we can go for the best option, which is median. So median is something which is actually not looking for the value, but is actually looking for the order and the position, and it is actually dividing both into 50-50, 50% and 50%. So median will be coming in this position. So median is a better option for the skewed data set, and same for the left tailed also. Median will be like coming in the median, like in the middle point only. So this is what your median is, and which is properly unaffected by the tailed, by the skewed data. So if the data is not a bell shaped data, like usually you will not get a bell shaped data like this in the real cases, mostly the data will be skewed. Okay, so for skewed data set, if you're going for the central tendency measurement, whenever you are going to do data analysis or feature engineering, for that cases you have to use median there. Okay, so now next thing I will be mentioning, that is again categorical data. When your data is categorical data, now categorical data means you don't have any quantitative value inside it, it's fully quality, it's fully qualitative. Now for categorical data, if you want to get any middle value, or your value is not a like exact word, I will be telling that any central point or any central tendency measurement which will be the representative of the entire value, and the data is actually in categorical format, means it's not like it's not a value, rather than it's in different format, or it's fully on string. Like let's suppose I'm just taking some example, like poor, excellent, average, good, and best. Now for this case, for this case, if I going to get a central tendency, what we can do, simply we can make it in order. So mostly for categorical data, which data can be put it into order, like which can be positively make, you can make into order, means ordered data. Ordered data means already we have discussed this type of data. this type of data is not a nominal data, or but we can say this is ordinal data. Now in the ordinal data you can perform this median as a measurement of central tendency. So the first step you will be doing, what you can make it in order, like poor, after that you can write average, after that you can write good, then best, then excellent. Now, by observation, is it possible to figure out which one is the middle point? So it's very easy. Good is the middle point. So this is how you can calculate. Here you can find out the median. So median is also good to find out as a measurements of central tendency for ordinal data. So what the advantages we already have got for this median? So I'm just listing down all the advantages. So first advantage we got, that is the effect of outliers. So it is like median is a measurements of central tendency which is not affected by outliers at all. Okay, so this is our first advantage. Now second advantage, it is better it is better for skewed data set. If you going to calculate any central tendency measurement, so for skewed data set it is better to use median. Now third case, we already have discussed that median works well median works well for categorical data. Now which categorical data? For categorical data which are actually, you can make it into order, means ordinal data. Categorical and more specifically in ordinal data you can perform median. So these are all the advantages of median. Now where you will be using, what are the use cases? Now this use cases, if I talk about in EDA, like in when you will be doing data analytics in EDA to find the missing values. Okay, for that cases you can use this median as a value for categorical columns. Okay, so in data analytics, in data analysis, especially in EDA, in missing value, in filling missing values, you can simply use median. Okay, and if you have skewed data set, for data analysis as well, if you have skewed data set, there also, to get the perfect central tendency measurement you will be using median. So this is all about today. Now in the next video we will be talking about mode as a measure of central tendency. So that's all for today. Thank you guys. Thanks for watching.